Hey physics fans, today we're talking about TP 9-53. In the problem, it talks about a falcon flying in a downward direction, grabbing a dove, and then that dove and falcon system continuing on in some direction. Well, that is some sort of impact, and we're going to use conservation of linear momentum to solve that problem. They asked us to calculate the final velocity of the falcon and the dove system as they continue along. So here's our picture. Next, we're going to go to our givens. Our givens, we have the mass of the falcon, the mass of the dove, the velocity of the falcon, velocity of the dove, and the initial theta. We have to assume that the system is closed and isolated in order to solve this problem. Now, moving to the solve step. All right, we're going to do a just before sketch. We're going to do a just after sketch. We're going to draw a coordinate axis. And then we're going to sum our initial momentum. We're going to set that equal to the sum of the final momentum. Next, we're going to go to our directions. In the x direction, we're going to set the momentum of the dove, add it to the momentum of the falcon, and set that equal to the momentum of the falcon and dove system. We're going to solve for the final velocity of the falcon and dove system, and then we're going to move to the y direction. In the y direction, we're going to find the momentum in the y direction of the falcon, set that equal to the momentum of the falcon and the dove system, and then solve for the final velocity of the falcon and dove system. After that, we're going to use the Pythagorean theorem to find the magnitude of the velocity of the falcon and the dove system, and then we're going to find their direction by using trigonometry. In the end, we have our vector of the velocity of the falcon and dove system, and it's equal to 22.1 meters per second at an angle of 32.2 degrees. All right, now we're going to go to the check step. In the check step, we see that units are good because we're talking about velocity, and velocity is measured in meters per second. We see that the least amount of sig figs is 3 in our problem. And then finally, we're going to check in if it's reasonable. Well, 22.1 meters per second is less than 28 meters per second, which is the initial velocity of the falcon, and is greater than the initial velocity of the dove at 7 meters per second. That concludes our video. See you next time. To the window, to the wall. All these problems solved. All these problems.